Hello, my dear quantum friends and quantum enthusiasts, and welcome to another episode here of the Hidden Quantum Champions at the Polaris School of Quantum. Today we are going to look at a company called Delft Circuits. And guess what? They are located in Delft, that I can already tell you. And everything else we will see in a second. If that sounds interesting to you, stay tuned and let's get started by looking right onto their website. So, here we are on the website of Delft Circuit. It says Delft Circuits. It says hardware for quantum engineers. So seems like we're at the right spot here. What we can see is we have these golden plates here with some cable connections and some connectors on there. And it says Delft Circuit and Blue Force join forces on scalable quantum I/O. So Blue Force is a name that we've heard already before. Probably, if you've at least watched some of the previous episodes, you might have heard about them. They are a cryostat manufacturer based in Northern Europe. Here it says, together, Blue Force and Delft Circuits provide an industrialized modular solution that allows customers to scale faster and more efficiently and ultimately control more qubits than ever before. So it's about quantum bits qubit technology, and it's about cryostats and cabling. So it's about, let's say, the solid state side of quantum technology. Let's scroll down a little bit further. Here it says scale your quantum success, not your cabling challenges. High density flexible cryogenic cable for microwave signals. So with that, we can already say now what Delft Circuits is actually doing. So they are a provider of those signal lines for cryogenic setups. And here it says cabling that empowers systems with thousands of qubits. Read more about enabling I/O in our roadmap. So there's also some roadmap, which we might check out later. Then it says increase your computing power by upgrading your channel density. So it's about getting more of those cables in a denser way down to the cold stage, and then nothing is in the way between your current challenges and your future success. By reinventing the cryogenic cable from round to planar, from single to channel to multi-channel, and from rigid to flexible, cryo flex offers unparalleled performance. So high density, low heat load, modular, and less points of failure. High density is of course important if you want to carry a lot of signals down to your chip. But then of course you also want to make sure that it's low heat load. And I've talked about that before. That has to do something with the fact that at the end, when you're looking at these low stages of the cryostats, you're talking about microwatts of cooling power. And then most of the heat dissipation that you actually have down there is coming from the signal lines carrying all that heat basically from room temperature down onto your chip. So you want to make sure that what you are using in terms of lines to go all the way down to this coldest stage, they should not carry too much heat down there. And that's why this is mentioned here. Then of course modular kind of makes sense. If you want to build these systems, you want to scale these systems, you don't want to strip wire by wire down there, but you want to have something that is modular, that you can scale easily. And then of course less points of failure also makes sense because that reduces your maintenance requirements. So these CryoFlex, flexible cryogenic cable, the state of the art in cryogenic cabling, says there are like different products down here. So there is the only available superconducting flex in the world. So a superconducting flexible cable. Get access to our unique flexible niobium titanium stripline technology, 1.5 dB, so decibel per meter of loss at 6 gigahertz of frequency, 9 Kelvin critical temperature, so you can run them in a liquid helium cryostat easily. Then 150 milliamps critical current, so you can easily run those 150 milliamps through the cable without generating any dissipation, so without generating heat also in that. And then less than 10 milliohm contact resistance, which is where you here and there connect the cable to some setup, right, to a chip, and then on the other side to your input. Then it says on-flex components, so only available on-flex components in the world. Get rid of clunky and expensive microwave components and integrate them into your flex. So there's an IR infrared filter, LPF low pass filter, and an attenuator of 10 dB and 20 dB available with those. So here you see the attenuator stage. If you are working in microwave radio frequency technology, you know that usually that you need certain attenuator values, and I guess that also plays for infrared filtering a role. And then lastly, we have here the unparalleled scalability and reliability at your fingertips. Leverage your current or new cryostat with extensive new wiring capabilities. So 32 channels through a K40 port, K40, K25 flex to PCB. So this is like a standard. KF40 is like a standard size for these for these vacuum openings, or for these openings of vacuum chambers and so on. And then here no mechanical interruptions on each stage, and less than 10 nanowatts of heat load per channel, which is again important when you go down to these very, very low temperatures. Quick note also here on the services that they have. So there's the CryoSuit simulation and design, which I guess is some software that you can use to do your simulations of, I don't know, heat load and signal transfer. There's a full in-house assembly and testing available, and on-site installation and testing is also available by them. Configure your wiring precisely engineered for your needs. So control your superconducting, your qubits with superconducting flux lines. That's what we've seen before, right? Our flexible niobium titanium strip line technology allows baseband transmission DC to 2 GHz, lossless DC bias current up to 150 milliamps, which is what we've seen before, and an infrared suppression up to 200 gigahertz frequency. Then there's the microwave lines. Drive your qubits with microwave lines. These are usually used to apply these gates, right? So fully integrated cryogenic radio frequency cables tailored for driving your qubits. Microwave transitions cut off at 8 gigahertz. Inline attenuation of 50 dB, optimized for noise suppression, and then benchmarked to be equivalent or better than standard coaxial solutions. And then, of course, taking all of the solutions here together, you come to the full I/O assemblies tailored for your application. This is what will then kind of go into your cryostat. You see also the different temperature stages here. And again, this chandelier-like look. Get your world-class cryogenic I/O and engineering service, customized flux, drive, feed, pump, and output lines, systems up to 1,000 channels, integration experience in Blueforce, Ligand Cryogenics, and Maybell. Some of them we've already seen in the Hidden Champion series, some of them might come later, right? Full cycle service from design to on-site installation to maintenance available. And then something about Delft circuits, the quantum industry's most trusted partner in flexible cryogenic cabling, leading customers from blue chip corporations to national labs, startups, scale-ups, and academia. CryoFlex products are found worldwide. And that's maybe also something to say. So I mentioned it also in earlier series. So you see that this market is still very full of providers that have a specific niche expertise, which is a very important part, like every single part that goes into designing those quantum systems, which are extremely complex, still requires a lot of niche expertise. And you see that there's some consolidation happening since the last couple of months or years, where you have either companies merging with each other, or in mergers and acquisitions, also companies getting acquired by others. But you also see more and more these strategical partnerships. Like, for example, here mentioned in the very beginning, you have Blueforce and Delft Circuit basically working together on a full solution, which includes then the cryo and the signal transfer side of things. But you also see at those companies, they are deeply integrated into the whole market. So they're not only catering a specific quantum computing company, they're not only catering a specific lab anymore, but they're really supporting to the whole market, including blue chip corporations. And with that, they probably refer to companies like, for example, Google. IBM, I think, is doing a lot of stuff themselves, but maybe even they could be buying here. We don't know. It's not mentioned explicitly. But this is just to say that even the big labs, they are not always doing everything by themselves, but they really also rely on these specialized hidden champions, component manufacturers. Going back to the website, so first of its kind, with a track record of over 8 years, Delft Circuit is one of the first suppliers in the quantum industry. Engineering excellence, a unique technology, outstanding facilities, and world-class experts in cryogenic I/O. Quick couple of notes about the company here also. They have some in-house facilities. Delft Circuit is equipped with over 1,000 square meters of production and clean room floor space. This allows in-house flex production, cryogenic and microwave measurements. A second fab line will be commissioned in 2024. So since it's 2025 now, there might also be an update here on that. World-class partners, so they're working with some very renowned partners here. For example, Deep Tech XL, Delft Circuits with our Series A investor Deep Tech XL. Delft Circuit is powered by high-tech leaders ASML and Philips, which are also very well known. And you also see here the high-tech Gründerfonds from Germany. As the first scale-up emitting from the Q-Tech quantum cluster, we are deeply embedded in its ecosystem. Then something here on the outstanding team. In our multidisciplinary team, we combine semicon fabrication, microwave, cryogenic, RF cabling, materials, theoretical physics, aerospace, telecom, quantum, software, and mechanical engineering disciplines, and also graphic design. And that we can, of course, see by the beautifully designed labels and all the nice type fonts and so on here on this page. And who would have guessed it? Of course, they're based in Delft in the Netherlands. That doesn't really come as a surprise given the name, right? Let's quickly check out also here the quick product overview. So we've seen that there are these flux line, the drives line, the signal lines, which are this niobium titanium strip lines, and there's also other ones available. There's mix and match here and readout lines. Fit for platforms, platform overview. Let's quickly check out which platforms we have here. So there are different ones that we see. So there's wiring ports. So that looks like a single stripped down solution here. Oh, sorry. Then you have the loaders. So these are basically inserted into an existing cryostat system, like into these chandeliers, right? So they go like a parallel line in your chandelier all the way down to the base plate, and then there are also turnkey solutions here, where I guess they integrated into the existing cryostat, and also says here full service provider, full-fledged solution. And if you're interested in that, then you can basically reach out to them down here. Okay. Let's quickly also check out the application side of things, because I think I already mentioned some of them, but let's look at what they are saying here. So there's the superconducting qubits and the spin qubits, which are, let's say, the solid state technologies that I was mentioning also before. We see here in the photonic space also single photon detectors, so the SN SPDs. So the semiconductor nanowire single photon detectors, which is also something that we've discussed already earlier in the series. These are, let's say, the quantum applications. So these two here, they come from the quantum computing side of things. And then for the photonic side of things, these play not only a role in, let's say, quantum communication, but they can also be interesting for quantum computing using photons or single photons. Then there's scientific applications here, so cryogenic-based science. Cryogenic-based science, like for example material and nanoscience, so looking at new types of quantum materials, which for example also I've been doing during my research times. There's astrophysics, for example detectors that have to be cooled down, and then there's also scanning probe, for example scanning probe microscopes that have to be cooled down to cryogenic temperatures. And there's also industrial applications here, so you see aerospace, biomedical, and then there's also automotive, as it seems, and it says even below, yes, automotive. And I'm very interested in that. I will not open this for now for this series, but you can be sure that afterwards, when we are done with today's episode, I will go and check that one out. But let's quickly, just as an example, hop into the superconducting qubits here, just so we see what is, let's say, the range of the solution that they are providing here with the cables and also the information that they are providing, I guess, positioning themselves as experts, also knowing where their components are playing a role in the system and how they make the difference, right? So, find turnkey quantum computing cables for your superconducting qubits. Delft circuits, multi-channel cables with integrated components offer a practical solution for enhancing the scalability of superconducting quantum computers. Our cables boost low heat load per channel and optimized distribution of attenuators, low-pass filters, and infrared filters for optimal noise reduction, all directly embedded in the cable. The reduced number of connectors and inherently efficient thermalization ensures the robust and reliable solution within the quantum computing industry. Delft Circuit provides full I/O solutions to facilitate seamless connections between any control electronic stack at room temperature and superconducting quantum processors at 10 millikelvin. We deliver turnkey cryo I/O systems, emphasizing ease of maintenance and compatibility. Contact Delft Circuits for a grounded and realistic approach to advancing your quantum computing capabilities. So, why pick Delft Circuits for your superconducting qubits? First of all, scalability. And that's something that we've talked about before, right? More channels in the same space because of the higher density that these systems have. But then also minimizing active and passive thermal load because of, let's say, the low temperature conductance of their cables, right? And then integrated filtering in the flex. So you also don't have to take care of the filter stages anymore. And there are all various types of filter stages. I remember when we were working in the lab, we had like pi filters at room temperature. There were copper powder and steel powder filters and whatnot. And some of them you even had to build yourself back then. So I guess it's much easier to have these types of solutions ready nowadays available. So reliability, also minimal points of failure tested and approved by leading customers, and in-house production with strict quality control. And then finally, there's also the service part here, so full cycle service, design, installation, maintenance, quantum cabling experts at your disposal, and turnkey I/O solutions. Now we come to the exact superconducting qubit case and how their cabling actually plays a role here. So quantum computers with superconducting qubits require a lot of different signals to be sent and received from the chip. Also in the intermediate steps, from room temperature to the chip, signal filtering is required. CryoFlex is designed specifically for this application and therefore tailored exactly to these specific needs. Below we show an overview of a typical superconducting quantum computer with the different I/O lines going from and to the chip. See below what products we offer to handle a system like this, and also take a look at our platform overview to see how these cables can be integrated into your system. And then here we see the different the scheme of the whole system. Time for a quick drinking break while we are looking at this. And then again, as mentioned before, so here you have the different types of signal different types of signals. So you have the feed here, as in the, for example, radio frequency feed, and then there's also the readout here on this side. You have the couplers between the different qubits. So you see here are the different qubits, 1, 2, 3, 4, and between them you have the different couplers. Here you have the feed line connected to your qubit. Then there's the bias flux as well, which you can see here, I think in the green. There's a drive as well in the red, and then there's the TWPA pump, which goes back here to the readout side of things. And now you have directional couplers in here, which, as the name indicates, they couple directionally, and these are all radio frequency components, right? You have isolators, low-pass filters. Low-pass filters are, for example, relevant when you go from the room temperature stage to the cold stages here. And I don't know, here it says temperature plates of the cryostat. So here you see the different temperatures as these yellow lines over here. So here you see this is the 100 millikelvin stage, which is the one before the super cold, before the mixing chamber where the cold stage is. So here is like where the 10 or whatever millikelvin are, and then here's the 50 millikelvin stage. And you see you have these low pass filters here, there's one here and here, and then when it goes to the qubit, you see one here in the feed line as well. And these, they basically make sure that the electrons here, which are sitting at room temperature, the ones with the high energies, they are being filtered out by this filter and get dissipated on these heat plates over here. Because if you think about electrons, they are fermions, so they are distributed at a fermionic distribution, which means they sit at a very sharp energy level when you are at zero temperature, and as you increase the temperature, the energy level of the electrons of the Fermi sea is spreading, is becoming wider and wider, which means you have higher energy electrons, so high frequency electrons, just by the noise at room temperature. And when you go down in temperature, you want to filter these out. That's what these filters, for example, are doing. And there's more in here. You see the HEMT, so high electron mobility transistor, being part of this as well, and also at the cold stage, and many more components. And here you see the recommended products for this. So there's a recommended product for the flux bias line, which is the niobium titanium based cryoflex optimized for flux bias signals. There's signal line recommendations and also other components mentioned here. Good. With that, let's quickly also check out the company. So go to the About Us section as per usual to learn a little bit where they come from and what their profile is. So about Delft Circuits, our story. The story of Delft Circuits started in 2016 when Delft Circuits founders Celluar Bosman, Paulian Bauer and Dan Kutenbrouwer, sorry if I pronounce that incorrectly, started their daily activities, frustrated by a lack of dedicated quantum hardware to support Cell's PhD at TU Delft. He then set out the goal to find solutions to the hardware nightmare of quantum computing researchers all over the world. In 2017, Delft Circuits BV was formally founded with beta testing in progress for our cryoflex products. Fast forwarding to now, we rapidly grew to a team of over 40 people and completed in-house cleanroom production and testing facilities. Our proof of concept microwave channels have matured to ready for sale product lines, and the next step in production capability and microwave components are being developed to expand our product portfolio. After our first sales started in early 2019, we are also proud to say that we have customers worldwide, ranging from world-leading national laboratories to global corporations, startups, and universities, with cryoflex technology making a difference in each of their setups. Company profile: Delft Circuits is dedicated to supply the best hardware of the quantum engineer and industry for the quantum engineer and industry. So far, we have realized hundreds of I/O modules for almost 100 customers. Whether in a leading national laboratory, a blue chip corporation, or an ambitious professor, clients find their way to our solutions. As an independent, dedicated quantum supplier, together with our customers, we make quantum technologies a reality. Quantum technologies offer revolutionary new capabilities. The industry is booming, but is still in its infancy. With quantum computing, a landscape of new possibilities will be added to the thriving ecosystem of high-performance computing, machine learning, and artificial intelligence. Quantum computing and internet, so quantum internet, brings new capabilities in information security and distributed quantum computing. Finally, quantum sensing will get a whole new dimension to a host of industries and sciences. In the past 2 decades, we witnessed an explosion in academic research and results. Now this development is transitioning into the first steps of the quantum industry, of which we are proudly part. With our team of 40 now, we are devoted to supplying the quantum engineers in industry, academia, and national labs with the best available tools, technology, and services such that they can focus on their real tasks. We are an ambitious group of people ready to realize our vision of paving the way for quantum technologies by providing innovative and relevant solutions to the hardware challenges of quantum engineers. We are dedicated to supplying the best hardware for the quantum engineer and industry. Together with our customers, we make quantum technologies a reality. Our mission: quantum technologies are revolutionary new capabilities for mankind and will most likely affect in even more segments of our lives than we can imagine. The industry is booming, but it is still in its infancy. With quantum computing, a landscape of new possibilities, with the added of the thriving ecosystem of high-performance computing, machine learning, and artificial intelligence. Quantum communication and quantum internet bring new capabilities. I think we've seen that part already. Our mission is to support our customers in making quantum technologies a reality by providing dedicated quantum hardware. I think we've seen that part already. Then quickly on their facilities. So it says in-house fabrication and characterization. Delft Circuits has an in-house fabrication and pilot production facility of close to 1,000 square meters located at the Kabel district. Our facilities contains a fully fledged production process capable of fabricating multi-layer superconducting circuits on flexible substrates. Our processes require expertise and equipment including metal deposition, lithography, chemical processing, high resolution inspection, and much more. Open bracket now from my side. These technologies that I mentioned earlier here are typical, let's say, semiconductor technologies, but of course they are not just done in a typical way. In order to produce these superconductor metals, you of course have to have additional expertise. But usually the tools that are being used are similar to the ones that you also find in semiconductor clean rooms. And again, also earlier in the series, we highlighted some of those companies working on those machines here. So back to the text. To validate our products, we have access to cryogenic measurement equipment for thermal and electro-microwave characterization from room temperature down to 10 millikelvin. New facilities in 2022, Delft Circuits has expanded to the historic cable factory of the Chicade in Delft. This is a short walk from our other location at the TU Delft. The site of the former largest cable company in Europe now facilitates more fabrication and office space. Then there's the Antonie van Leeuwenhoek Laboratory, so VLL, within the Delft Quantum Campus. We have one of the largest research clean rooms in Europe. Here we have access to most of the possible fabrication and inspection technologies. We can deposit many superconductors, metals, and dielectrics through evaporation, sputtering, ALD, so atomic layer position, LPCVD, so PECVD, so plasma enhanced chemical vapor deposition, and laser pulse chemical vapor deposition, and so on. We have access to optical and e-beam lithography and inspection like AFM, so atomic force microscopy, and SEM, so scanning electron microscopy. With more than a decade of experience in this cleanroom, we are the ideal partner to fabricate our most challenging circuits. Investors, Delft Circus is backed by world-leading partners, and I think we've seen these ones here before. Also, they are part of public projects, like for example the Horizon 2020, which is a European-funded project, and some others that are mentioned down here. With that, I leave it to this page with, I think, the founders and the team over here to close today's session. I hope you liked it. If so, please make sure to leave the video a like. And if you found it interesting, please also share it with a friend of yours. I'd be happy to see more quantum enthusiasts around this channel. As always, make sure to stay hydrated and see you in the next one. Bye bye.